Hello friends, welcome to this third video on set theory. This video will concentrate on the algebraic laws of set theory. We already used the Venn diagram to represent the relation between the universal set and any given set called as A. These laws of algebra can be easily understood if we have the Venn diagrams in mind. Okay, come on, we will move on to see what are them and how we can associate them with. The binary operation of sets, union and intersection satisfy many identities. Identities are nothing but laws. Okay, so you can directly use them whenever you want, like they are going to be already proved quantity. You need not have to you put any effort proving them, so you can use them wherever necessity to satisfy any relationships. So let A be any subset of the given universal set U. Then the following identities or the laws hold. The first law which we are going to see is going to be the identity law. What does the identity law say? The identity law says that whenever you take A union with phi, phi is going to be our null set. Phi is going to be the null set. So what do you mean by union? Union means your OR operator, keep it in mind, and intersection is nothing but our AND operator. So anything you take union with null set, so combination of the set and the null set will be your A itself. And what is going to be common to the set and the universal set? It is going to be again A. You can understand it in this way, like identity. You can imagine about your ID card. What is your ID card doing? It is going to reveal the data of yourself. It is going to take you as your input and reveal you as your output. So if A is taken as input and A is got as your output, so the output got as A, you can call it to be identity law. The next comes your domination law, which dominates. Okay, so when you take A union universal set, you know that universal set is going to be the bigger picture. This is going to be our universal set. And what is A? A is going to be a subset of it. So what will be the union of both of them together? It will always be the universal set. And when you take the intersection between A and null set, so what is common to the set and the null set? Nothing is there in the null set. So if nothing is there, what is common to both of them? It is going to be your null set. Okay, so universal set and the null set dominates the quantities over here. So you call it to be domination law. Next is going to be the idempotent law. You take an input, you get the same value as the output with using your union and intersection. So over here, the identity law takes your union and intersection with the universal set and the null set. But in idempotent law, the union and intersections taken with the set itself. So that is going to be the major difference between identity law and your idempotent law. The next comes the inverse law. So what happens, or it is also called as the complement law. So whenever we have the set A, the elements that are apart from A will be referred as its complement. So this portion which you have over here, right? So this entire part over here, which is apart from A, will be called as the A complement. Okay, so this is the part which is called by A complement. So whenever you take A and the union of A complement, so what is A and A complement put together, you will be getting your whole of your universal set. And what is going to be the intersection? Intersection is common. Is anything common to A and your A complement? No, there is nothing going to be common to my A and my A complement. So the intersection will always be empty over here. So this kind of association with the Venn diagram helps you to easily understand the law. You need not have to by heart them. You just think logically what happens. Then there is no need for by hearting quantities. So that can make things much simple for you. Okay, and next comes the double complement. What do you mean by double complement? Take complements complement, that is called as double complement. So the inverse will be your A itself. So that is going to be called as your double complement law, or it is also called by the name involution law. Okay, so we are the first 5 sets of laws over here, and now we move on to the next set of laws over here. The next law is called as commutative law. Okay, this commutative law you would have already come across in your basic classes, like when we use addition and multiplication. So we say that 2 plus 3 is the same as 3 plus 2. What do we call this law as? This law is called as commutative law. So whenever you shift your numbers and the value of the data doesn't get changed, then such a law is called as commutative law. The same thing will work for multiplication too. 2 into 3 is the same as 3 into 2. Okay, so this multiplication and addition satisfy commutative law. In the same way, our union and intersection also satisfies commutative law. That is, when I interchange the elements A to B and B to A, the law remains to be the same. So what do you call this as? You call this as commutative law. Shifting of the member doesn't alter the value of the law. Okay, so that is going to be your commutative law. Next comes the associative law. It is just an expansion of your commutative law. So instead of two members over here, we take the third member also, A union B union C. So we call this as A union B union C. What we do over here in commutative law is we shift the sets, but what happens over here is we shift the brackets. So when the brackets gets shifted, then what law is called as? It is called as associative law. Okay, so it holds true for union as well as it holds true for intersection. The next one, eighth one, comes to be the distributive law. A union B intersection C is A union B intersection A union C. So normally when we write exam, there will be a confusion. What is going to be the associative law and what is going to be distributive law? I'll give you an easy trick to remember. Whenever you have the operator to be different, okay, over here, what is the operator which we have? The operator, first operator over here is going to be union, and the second operator over here is going to be intersection. So whenever you have different operator, it is going to be distributive law. You can remember it in this way. Okay, different operator, then it is distributive law. And now when it comes, all the operator are the same. Okay, so when all the operator are the same, here also union, here also union, when all the operator are going to be the same, okay, then you call it to be associative law. So all operator are the same, then is going to be associative law. Okay, you can take this as a clue and remember it. When there are two different operator, it is distributive law. When all the operators are the same, it is associative law. So what happens in a distributive law? This union distributes over B and union distributes over C. So it is A union B intersection A union C. Okay, here also you will see it is union, intersection and then union. Different combination you will have. Okay, leaving the distributive law for you to understand. Next we move on to the absorption law. A union A intersection B. Again it is an mimic of your distributive law. The only thing is that union and intersection, two different laws are there, but instead of three operator A, B and C, I have only two sets over here. One is A and the other one is B. So we don't have three different sets A, B, C. We have only the set A, union and A intersection. So always the output will be the same input, which is going to be your A. The last comes the De Morgan's law. A union B, the whole bar equal to A bar intersection B bar. When the set come outside the bar, then the operation changes. You can take it in this way. When outside the bar, this union becomes intersection. That is going to be the main change over here. When you come outside the bar, the operator changes. Okay, out and you change. Okay, so union will become intersection and intersection will become union when you apply the complement. Okay, so that is going to be the De Morgan's law. So we need to understand them using the Venn diagrams, then these laws need not have to be memorized for, but it will easily be understood and can be kept in mind. When it comes for examination point of view, it is not necessary that we will be frequently using all the 10 laws. It is just sufficient you memorize yourself with the De Morgan law, distributive law, associative law, and then majority of the problems can be solved easily. Okay, so these things can be easily visualized through the Venn diagram. So when it is asked for, you can go for the answer by thinking about the diagram. And when it comes for the problem solving part, just try hard to get your De Morgan, associative and distributive law, then things will work easily. Now in the next session we will see that what is meant by the principle of duality. The principle of duality says that the identities remain to be the same, they don't change when I am going to follow 4 rules. What are the 4 rules? When my union is replaced with intersection. My second rule, when my intersection is replaced with union. The third rule, when my universal set is replaced with the null set. And the fourth rule, when my null set is replaced with the universal set. So that's why every law which we have written over here has 2 parts. So when we apply the rule, we can see that when union changes to intersection, the universal set over here changes to the null set, and the universal set over here changes to the null set. So if I want the dual, what I will have to do, wherever I have the equivalent quantity, replace it. Replace union with intersection, replace universal set with null set, and replace this universal set with null set. So this is identically equivalent to this by the principle of duality. So we need not have to memorize them separately. You just take one of them, replace your union with intersection, null set with universal set, then the law will still remain to be the same. That's what is the law of, or the principle of duality. Duality says that the statement doesn't change by interchanging the 4 components: union with intersection, intersection with union, universal set with null set, and null set with universal set. The law which is obtained by replacing these quantities is called as a dual, and the original law will always be referred by the name called as primal. Okay, so the base law will be called as primal. The one which you get by interchanging will be called by the name dual. The next one, we will see 2 problems by using set identity, how I can solve or prove the component A union B, A bar union B bar, union A intersection B intersection C bar. So there is going to be bar, so we think that we will make use of our De Morgan law. So first step, let me combine this A bar union B bar. By De Morgan law, A bar union B bar is going to be equal to A bar union B bar is equal to what happens, A intersection B the whole bar. Okay, so if I remember it, so it is A intersection B the whole bar union. So next I have A intersection B intersection C bar. So this is my LHS and this is my equality. Okay, now I am going to combine this. I notice that one is going to be union over here and the remaining quantities are intersection over here. So let me introduce a bracket between these 2 numbers. That is, since it is intersection and intersection, bracket will not change the value. So this is called as associative law. Whenever you use a law, make sure that you write it over here using De Morgan's law. De Morgan's law. I have made the first one into the part like this. Okay, so now comes the next part. What I am going to do is take this portion to be equal to the element called as A, this portion as my element B, and this as my C. So what do I know now is, I know that A union B intersection C. So this A intersection B, the whole bar, is going to be treated like my A. A intersection B will be treated like my B, and C bar will be taken as my third element C. One is union, the other one is intersection. The things are different. If it is different, distributive law. What is distributive law? A union B intersection A union C. So we will apply this over here. So what will happen? A union B. So it is A intersection B bar. This is my A union. What is in place of B? A intersection B. Okay. So this is my first part. Intersection. Now A. Again, what is my A? A intersection B bar is my A union. What is in place of C for me? C bar is there in place of me. Okay. So what law we have made use of? We have made use of the distributive law. Okay. By distributive law. Next, I will move for the next thing. Now I have something called as A bar union. The second thing is without bar. So this is A. What is A union A bar? So when I combine the set with its complement, I will be getting the universal set. So what will happen in the next law? What will happen over here is these two parts can be combined to universal set intersection. So this will be A intersection B the whole bar union C bar. So what is this law called as? U dominates it. So this law is going to be called as your the A and its A complement. What will be A and A complement? Called as inverse law. So this is using your inverse law. Inverse law. Now the next thing, what happens over here is when I take universal set and intersection any set, what will be common to the universal set and any set? It will be the set A alone will be common to universal set and set. So universal set and this entire quantity you take it to be the set A. What is common to both of them? The set will be the only thing that is common to both of them. So what we will be having over here will be A intersection B, the set itself. Okay. So what is going to be used over here? This is being called as, when you take A union the universal set, you get the same thing. You call this as identity law. Okay, next line. So let me again, I need you keep it in mind. What is that you want on your right hand side? It is A bar union B bar union C bar. So this is intersection over here. How can I split this? Yes, very well. A intersection B, the whole bar can be written as A bar union B bar using which law? Yes, you are very right. It is called by the name De Morgan law. De Morgan's law. See, now this is not the only way in which the problem can be solved. The problem can also be approached in very different way because it just uses logical ideas. Okay, so instead of using De Morgan law or distributive law, if you are able to use some other laws which are over there, like the 10 proved laws, and able to get your answer also, it is well and same. So it is correct only. Okay, right? We will move on to the second problem. So the second problem says that if A and B and C are going to be any set, we are going to prove that A union B intersection C the whole bar is C bar union B bar intersection A bar. Okay, so we will quickly use this, split this using your De Morgan's law. Using De Morgan's law, I will have this whole bar to be split as A bar intersection B intersection C the whole bar using De Morgan's law. Okay, step 2, let me again split this using De Morgan law. A bar intersection, so this becomes B bar union C bar. Okay, now you can see again what we have used is De Morgan's law. Now my final answer has A to the back, so let me pull this to the front. So I have B bar union C bar with an intersection A bar. So I have used flipping the element, what do you call it as? Commutative law. Once again, use the same commutative law to flip this element here. I have C bar union B bar intersection A bar. So I have got the answer which is required for me using the commutative law. That's it, student. The problems may at first strike seem a little tough, but when you are continuously applying the laws and practicing more of their problems, then things will become quite easy for you. Happy learning will make math simple. Thank you.